By the end of this session, you'll be able to define the centre of mass, you'll be able to correctly locate the centre of mass of regular objects, and you'll be able to explain how the centre of mass of an irregular object can be found. Now, if you balance a ruler or a pencil on your finger, what you'll find is that usually it balances best in the centre of the pencil. If I try and balance it on the edge, it doesn't work, it just falls down. Why is that? Well, although this pencil has mass all the way through it, has matter all the way through it, we can treat it as if all its weight is acting in one point, and we can also define a centre of mass. And the centre of mass is the point of an object where we can take its entire mass to be concentrated. If we're doing calculations with this pencil involving its mass, then we can treat it as a point pencil, as just a single point where all the mass is concentrated, and we can ignore the fact that actually it's got length, certainly for that sort of calculation. So the centre of gravity and the centre of mass usually are the same point in a uniform gravitational field. Now obviously on the Earth we are experiencing a uniform gravitational field. If we took our pencil to near a black hole, then the centre of gravity and the centre of mass may not be in the same place. So let's think about the centre of mass for a regular shape. If we have a circle, then the centre of mass is simply in the middle of the circle. If we have a rectangle or a square, again, the centre of mass is in the centre of the object. Now, that's okay until we come to a donut shape. And it's interesting to note that the centre of mass of the donut shape, okay, and I'll put a picture here, you can see, if I suspend this, the centre of mass is actually in the middle of the hole. So we can have a centre of mass that is outside the main body of an object. In this case, it's in the hole. Now the reason why we can suspend things to find their centre of mass is to do with moments. You remember that if there's an unbalanced force, then we have a turning effect. And if I hold this shape here and let it go, it falls, as you would expect, vertically downwards. Now the reason it does that is because when I'm holding it out here, the centre of mass will try to be directly below the pivot. So if I hold it upwards, the centre of mass is now above the pivot, so when I let go, it drops down. And if I was to draw a line directly down below the pivot point, and do that a few times, we would be able to locate the centre of mass. So we can do that just by putting a hole in an irregular object, suspending it, and drawing a straight line. And that way we can work out its centre of mass.